Hello, everybody. Good afternoon. How's everyone feeling? Good? Friday afternoon, post-lunch. Everyone's looking good. Everyone enjoying the conference so far? Excellent. Well, I'm excited to be here. My name is Philip Vaughn. I'm the group program manager in the Microsoft Sync Framework team. We own the Sync Framework, which you've heard some about, and we also actually work on some of the database replication technologies. This talk is primarily going to be around sync services for ADO.NET. We're going to touch on the things in Visual Studio and then talk about some of the new things we're doing. I'm sure at this point everyone's seen more than one PowerPoint deck this week, so I'm going to try to keep this as demo-focused and interactive as possible. So I really want to encourage you guys to participate. If there's things you want to see or questions you have, don't hesitate to jump in. If we start running off on time, I can kind of manage the presentation from there, and maybe I'll hold off and move on. But I really want it to be useful and hopefully even somewhat entertaining for you. And so with that in mind, here's how we're going to proceed. The first thing we'll do is introduce the Sync Framework. I'll touch briefly on what the goal of the Sync Framework is, why Microsoft invested in it, and how Sync Services fits into that. We'll do a small little touch on offline database synchronization, basically a little bit of a comparison between existing things like merge and sync services. And then I'm going to spend a good part of the presentation actually unfolding to you as a set of developers what it actually means to build an offline app. What I'm going to do is walk you through sort of change by change and somewhat query by query of what it means to build sort of an application that works sort of like Outlook and Exchange do, where you work disconnected from the server. And fortunately, the things in Visual Studio that were shipped in Visual Studio 2008 are flexible enough that you can use that today regardless of whether you're using SQL Server or not. And then we'll actually touch on the things in SQL Server 2008 that make that much better. And then lastly, we'll kind of close on how we're adding collaboration capabilities to sync services, so you can do not only the offline kind of Outlook Exchange, but you can also share data across users. The idea being, you know, if you're disconnected and on an airplane, perhaps you could still synchronize between a peer. So with that, I think primarily what I'd really like you guys to understand walking out of here, besides the stuff that's kind of on the board, is just if I can bring sync down to earth a little bit for you. Many folks complain in the past that synchronization is sort of a difficult problem. It's something that appears easy from the outside, and they get into it, and it becomes a little bit more difficult than they thought. And so I'm going to try to walk you through step by step on how, by just writing another query or adding extra metadata on the server, we can actually extend sync. And then I want to show you how some of that stuff's taken care of in 2008. So if you guys walk out of here feeling like you spent an hour of your time in Barcelona and kind of understood what it meant to build an offline application, I'll feel successful, and I hope you think it would be worth your time. So with that in mind, let's go ahead and move on. So the Sync Framework really had two and has two key sort of scenarios that we built it for. Again, the first being this offline aspect. We really want to make it easy for developers to build Outlook-style kind of cache mode applications. It's not a new sort of idea. What's new is us making it somewhat available for developers. And the idea is that, you know, the mobile information worker, the person who drives around in a truck and delivers packages, those sort of scenarios we really wanted to empower developers to build. In the past, it's kind of been end-to-end replication products or completely write your own from scratch. The other thing we wanted to do, and it looks like my slide got cut off, I apologize for that, is allow people to synchronize data, really all types of data in any sort of topology or form, and we call this sort of collaboration. And the idea here is that when I want to share information, it's not always centralized in a server, and so we wanted the framework to be capable of doing more than that. So if you wanted to synchronize two different types of data from two different stores, or perhaps even change the topology to where you'd go from a server to a client to multiple clients, and then maybe periodically with a server, well, we could allow that. And so inside the Sync framework, we really have three kind of key pillars that developers can write applications. The first of these higher level services, And these are useful for the primary, this is going to be the primary focus of this session, which is I wish to take my server offline. This is kind of the key role of sync services for ADO.NET. It was about making database applications, making it very easy to take databases offline. We also have a set of endpoints or a set of providers that we ship inside the framework that allows people who want to synchronize, let's say, a file system and Outlook. If you had V cards in a file system and you wanted those contact files to be synchronized in Outlook, which is a different store, you could do that. And then, of course, as the runtime, we really wanted to make it, of course, possible for people to add sync to their stores. So we couldn't provide endpoint support for everything. And so the framework also contains support for that. And so then inside of the framework, we really end up with an agent that knows how to do the actual synchronization, support for common stores and protocols. That's the endpoint you saw. And then, of course, a runtime that lets you build those things. And that's really what makes up the core Microsoft Sync framework. So with that, taking a look at offline sort of applications, you'd find that if you take a look at Sync services and the things we have, and if you may be familiar with it, actually just a quick raise of hands, who's used Sync services for ADO.NET inside of Orca so far? Tried it, played with it, any of that? No, who went to Steve Lasker's talk maybe earlier where he went through kind of building caching and taking data offline? Anyone go to that? Okay, a few more hands. Okay, so I have a fairly demo-centric presentation, and I'm skipping over the Orcus demo. If that's something interesting for folks, I can come back to that or even include it now because I can kind of adapt it on the fly. But what we started with, and just a quick note was the goal, of course, was to make it easy for people to build offline database applications. And if you go far enough, you start to ask yourself the question of how does that compare to existing products like Merge Replication, which are designed to basically take data from a server, transmit it locally, and then synchronize back up. And in fact, they can be similar, and there is some overlap. But when we started Sync services and we started the work we were really after kind of the problems that people were expressing about end-to-end products. Primarily being the idea that they created extra metadata on the system, there were triggers in place, you had to kind of agree that this would be the same vendor database on the client as the same vendor database on the server, and we were hearing from developers that they wanted a bit more flexibility and control. And when the other thing we found is that even with an end-to-end product, people still felt like they didn't understand how it behaved, but yet when they went to go write their own, it still felt like somewhat of a black art. And so kind of these conflicting requirements is kind of what drove us to this idea of wouldn't it be great if we had basic synchronization functionality in Visual Studio that allowed people to build kind of these simple offline applications that could be extended over time to where people didn't feel like they were kind of boxed into an end-to-end product. And so with that in mind, we have kind of these two sort of pillars that I look at and think about. And you know, at the end of the day, we're still going to continue to invest in both sort of tracks. We want to make sure that for folks who want an end-to-end product where it's kind of a buy versus build scenario, they can configure something on our database product and get nice offline synchronization functionality with all sort of the big bang features and not have to write a lot of code. On the other hand, though, we acknowledge that certain people want to do just something simple and may not want to pay the price of configuring a server-side product for that. And so for that reason, we give people Sync services, and you'll see in this presentation how you can pretty quickly go from something basic to something reasonably sophisticated. It's just a bit more code. And so Microsoft will continue to invest in sort of both paths because we have customers that want a little bit of both. We just previously kind of had the left-hand part of the balance and not the right hand, and Sync services brings us a little bit more into where we have two offerings for folks who want to build sort of mobile or offline applications. So ultimately what's inside of Sync services is, again, it's this idea of being able to take a database offline. It was designed for all the kind of environments that you'd come into contact with, meaning that it works both in a two-tier environment where I want to connect directly to the database server, as well as an in-tier environment where I have a web service or an app server, something that my application talks to. It's targeted at caching and offline in Visual Studio. That gets extended to collaboration in SQL 2008. And the nice thing about it is it works against any backend database, any database. It doesn't require just SQL Server, and it actually has things built on sort of SQL Compact Edition to make it easy to do sort of the client portion of it. And what you end up with is that with Visual Studio and kind of a backend server database, you really have most of what you need to take a database application offline. Inside the actual product, we have Compact. It's the first time we've allowed SQL Server Compact to run on all editions of Win32. So before, Compact Edition was a device sort of database, and we've now allowed that to run on all the sort of Windows platforms. You could, a slight correction, you could run it on tablet PCs before, but for the majority of people who wanted a client database, you had SQL Express as your choice, and there wasn't really another embedded offering from Microsoft outside of kind of Access or Jet. With Compact, we now give you the ability to have a client database in Visual Studio that's very easy to program to, but it's also easy to deploy, which is sort of a key requirement in these offline cases where people are working disconnected from the head office and they don't always have access to a super fast network connection to install big pieces of software. Of course, it includes the actual API, and with Sync Services, it's based on ADO, meaning that we've taken the concepts people are familiar with ADO, like data adapters, and we've just extended them slightly to include the things we need for sync. The conflict tracking is a bit more robust. The idea we have like an incremental query on there, so instead of just select, we have select incremental. So if you're comfortable programming ADO, the goal is, and I think we did a reasonably good job, you'll have to tell me, of extending that to allow people to just learn a few more key concepts, and they can now start to do sort of sync. And then, of course, lastly, in the designer experience, we built a designer in Visual Studio that you point at your server that helps you write the queries to pull the changes off the server down to the client. So with those sort of three things, we have what feels like kind of the Outlook side of the kind of offline client. Of course, you still have the application to build and write, but the core sort of ingredients, the raw materials, are down on the client for a developer to be able to take advantage of. And so for the next sort of segment of the presentation, I want to kind of introduce the concept that the more things you want to do in synchronization, it's really just about extending it. A lot of people don't see that when they go into it, and so they kind of learn it after the fact. And so what I'm hoping to do is give you a slight walkthrough of how we can actually take a backend database and extend it from caching, which is, when I mean caching, I mean just like one-way data. If I just want to maintain a list of products in my client database, I'm going to show you how we can do that. If I actually want to take the database offline, meaning that I want to make changes and send them back to the server, I'm going to show you how we can do that. And then lastly, I'm actually going to show you how, if everybody in the room was making changes and sending it back to the server, we could still do that but detect conflicts appropriately. And so all those sort of scenarios kind of sound very similar, but kind of the thing about sync and the joke we make in the team is that it's all corner cases. It's all things that you didn't necessarily think about when you got into it. And I think by laying it, the sort of the presentation out this way, you'll get an understanding for what's possible and how you can build an offline application, but you'll also understand when we get to what SQL 2008 provides, how some of the features there make this that much better. So if I had imagine a scenario where I have a products table or an orders table, and I just want to synchronize the data locally. I have 1 million products in my product catalog, and even if I'm connected to the server to send the updates, it'd be really nice if I could put a list box on that or do something with it and not have to download 1 million records every time I start my app. So what I'd likely choose to do is use a compact edition database or a small, lightweight embedded database and just periodically maintain that product list. And in order to do that, you'd find that you'd need a bit of information both on the client and on the server. On the server, you'd need this concept of what I call a database timestamp. It's actually, there's a DBTS function in most server products, but what it tells you is, the last thing I did was this. And if you keep that information on the client, when you come back, you have a moment of reference to say, when I come back to you, last thing I knew was this, what's changed since then, and you have a beginning point to start to get new things. you also need some sort of a create time and an update time on the actual rows themselves. The first timestamp is sort of database wide. The next timestamps are kind of at the row level, the individual record level. And they actually tell you what's changed on that row, or has that row changed. That, coupled with the things on the right side, kind of give you the ability to couple both the client and the server, to where now the client would actually know what to ask the server for, and the server would ultimately know how to respond. And so with that, that's going to be actually the foundation of our first demo, and I'm going to actually show you how we would actually walk through doing this. Is everyone, just before I get into this, is everyone kind of following me so far? Does anyone have questions before I move on? Does everyone kind of understand the scenario we're at? Because before I jump into the code, I think it's sort of important that everyone's kind of on the same page. So raise your hand if you would like me to explain something or have a question. How about raise your hand if you're only going to raise your hand if I give, like, offer something? Okay, one honest person, that's outstanding. Okay, so the first thing we're going to go through and do is create this little test database inside of the SQL Server. This is running against Express 2005, so no real tricks here. I should note while I'm doing this, the Visual Studio Designer actually does a really good job of helping take care of a lot of this for you. We actually thought through a good bit of it, and actually sets things up on SQL 2005 for you. So if you're using SQL 2005, the designer will do a lot of the heavy lifting for you. But if you're not using SQL 2005, or you have a different system, then it's useful to have this kind of knowledge to walk through. So I apologize. Apparently, I have an open connection somewhere to that database. Let's try to drop it again. I just want to make sure we kind of start clean here on the demo. It's always the challenge with so many demos is some of them are going to hiccup, so please try to be patient with me. If not, we'll just shut down the GUI and relaunch it and go from there. So how many people in the audience have, like, used an end-to-end replication product while I'm setting this up, so I have a reasonable idea? Who's tried to use, like, merge replication or anything like that? Okay, who has kind of a current offline need in their company, like if they could do a nice easy cache or an offline? Awesome. Okay, so this will all be hopefully fairly relevant. While that's running, let me get the next one going. Okay, so I'm going to assume that runs, and if not, we're going to move on. So, okay, so the first thing that you need to do, kind of with that slide in mind in the back of your head, is we need to have some sort of a timestamp on our orders table. So the first thing this change does here is it alters the table order, and it adds a timestamp, and it sets a default to be the database timestamp, which is that @dbts +1. It does the same thing to the orders, to add something for orders, where it creates an update timestamp for orders, because keep in mind, we may want to see what's been inserted versus what's been updated, because I could have a situation where I want to distinguish between new things and updated things, and this update timestamp allows me to do that. And then I'm going to have basically a small procedure that I create that actually does what you'd imagine, which is selects the changes from the orders table based on an anchor that I'm going to pass in. And what it's essentially doing is saying it's that database timestamp value we discussed before. It's going to say, I want all the new orders from the system. And that's essentially all it's saying, greater than this and less than this. So everything that I'm interested in. And then the rest of this code is going to basically create a procedure to do that. And essentially, this lays the foundation for what you would need to do to maintain a cache. And with this small amount of code and adding 2 timestamps, believe it or not, you can actually have a product cache or some sort of a product catalog like we discussed before that could stay up to date. And so I'm going to run this code really quick. Fortunately, that all worked. And then I'm going to, there's an update proc that does the exact same thing we discussed. And then here's the actual test for that code after we get to this point. So, I'm sorry, can you repeat the question? Yep. Good question. I think it's just no real scientific reason. They're both timestamp. They're both timestamp values. DBTS is a timestamp, and timestamp is a timestamp. I believe DBTS returns a timestamp value, so it shouldn't matter. The only reason I could think of is if I'm wrong, and DBTS is actually a bigger than a big int. Steve Lasker's in the back with his hand up, which means he has the answer. Ah, thank you, Steve. You're absolutely right. So for the tape, since it's being taped, the answer is, and a prize of the day goes to Steve, is that you can only have one timestamp on the table. So we needed basically a big int. And again, this is on SQL Server we're talking about here. So what I'm going to essentially do is get it to this point, hopefully, okay, and then I'm going to go through and update the orders, return the changes, and if everything is going well for me, this sent received anchor. Oh, sorry guys, I need to get my variable declared in the right spot. We're just going to run the whole thing. And at this bottom of this demo, you'll see that I stuck one row in there before I fetched the timestamp, and it returned that row. This piece of code here inserts a new row. This sets the anchor to the database time. This captures, this is the proc that I showed you that wrote the new inserts. And that's how we return the changes. Last received. Sorry guys, hold on one second. It's important that I get through this. We're going to keep bombing on it. Oh, I need to hit the declare for it. Sorry about that. Yep, and it gave me a duplicate key error, which is correct because I didn't truncate it. So at the end of the day, it stuck that order in there, and this returns ultimately the updated order. And so to review real quick, we've added an update timestamp and an insert timestamp. Actually, one of them's not a timestamp, but we've created two values that tell us what's new inside the table. And then essentially we've written a query that selects off those two things and uses the server database time to tell us what's new. And by doing that, we're able to download all the new inserts and all the new updates to the local client. And so what we end up with is the idea that we're maintaining sort of the new things that appear in the cache, but what we haven't done yet is actually track the deletes. If I want my cache to maintain consistency over time, I also need to track deletes, because keep in mind, once the data is deleted from the table, there's actually no help that a timestamp is going to provide you. You need some mechanism to capture the deletes. And commonly what's done is that there's a delete table added to a delete table with a trigger added to the source system or to the backend server that captures those changes, and then the client basically writes a separate query that looks in that table for changes greater than that same timestamp and downloads them. And so with that, hopefully this time the demo guides will be a tad bit with me, and I can go through and show you how we're going to run the delete statement. And I'll move through this one fairly quickly. What this does is essentially creates a new table called orders tombstone, and in the world of sync we commonly call tombstones the deletes. And it's going to create a trigger, as you can see here, that's going to capture the changes from the deleted trigger and insert them into the order tombstone and keep up with the time that it happened. And what that's going to allow us to do is to, of course, fetch the deletes as they occur. And you see, if I run this code here, we actually deleted a row, and we see the delete timestamps returned for the first order that we'd inserted previously. And this proc here, I'm going to generate it because it's later for the demo, but you get the idea at this point. It's really trying to make sure that all the new deletes are kept up with over time. Why is this thing doing that to me? Okay, not important. So you get the idea. And so with that, what we have is a cache that's being maintained now because we're tracking the inserts, we're tracking the updates, we're tracking the deletes. But what we haven't figured out is how do I keep the cache in sync with the server? Meaning that if I want to download the actual, if I want to make a modification to the cache, how do I send that back up to the server? And in order to do that, of course, we have to write code on the client or on the cache to actually send the changes back. And for sake of vocabulary, we typically transition here between the idea of caching, and we call this synchronization because now I'm actually keeping two individual databases in sync. And so now we're starting to think typically a little bit more about sync. And you notice there's nothing really required on the server because all I need to do is track on the client. And again, as I mentioned before, one of the nice things about Compact Edition inside of Visual Studio is that we actually built the same change tracking that I was sort of showing on the server side by adding those columns. We actually built that in the engine. And so when you ask for changes from SQL Compact Edition, they're just readily returned from the API. You don't have to do any of the work to alter the table and do all these things. That's part of what we did with Sync Services in Compact Edition, was to couple the two together so that the changes are very easily captured and sent from the client up to the server. And so that's kind of like a key fundamental benefit of using Compact, and it's something that we're looking to do with SQL Express over time, but it's one of those situations where we think if you're using a Microsoft client database, it should be the best database for sort of building these synchronized and cached databases relative to a server. And so this next demo, I'm really going to hurry through because it's simply basically data access. This is no real difference than what you would do if you were writing changes to the server in any way, shape, or form. There's nothing really special about this. It's simply writing a bunch of procedures that apply changes on the server using stored procs, and it's inserting the data into a normal sort of stored procedure. So there's nothing really unique here about this. In fact, it's probably the same code you guys have seen a dozen times before. And so all this guy is going to do is allow the client application to have a set of stored procedures to call to send up the data. So, but nonetheless, it's kind of a required step if you already didn't have that infrastructure built on your client application. And so that's fine. So let's stop and check where we are. We've got a cache that's being maintained. I have the inserts being populated. I have the updates being populated. I have a way to determine if I actually want to receive that data or not. I have deletes coming down because now I have a trigger on the tables I'm tracking, and I have a way to maintain the cache. And now I'm actually modifying the cache, getting the changes out, and I'm sending them up to the server database. Well, the thing that's really missing from here is this idea of loopback detection, which is if I upload the changes and you upload the changes, or multiple people upload the changes, I can get the same changes back. And the reason for this is slightly subtle, but when I send something from the client up to the server, it's going to increment that server timestamp that we're using before. And when I actually ask the server what's new, I'm going to receive my changes right back. And then when I ask the client what's new, I'm going to get the changes that I just downloaded from the server. And so we're going to end up in sort of this infinite ping pong that'll eventually straighten itself out. But I don't want to waste my time downloading new data or downloading data I don't need and uploading data that I've already downloaded. And so what we do is we add this idea of a client ID. And what a client ID does is it allows me to see the changes that originated from me so that I don't download them again when I select from the server. So really all we're going to end up doing is, in our upload inserts, our upload updates, and our upload deletes, I'm going to set some sort of a client bit that lets me know where the change originated from. And then when I select at the top, I'm going to select and I'm going to add to my where clause this notion of what client did these changes originate from. And this requires you, of course, as a developer to keep up with the clients on your local machine. But again, the Sync Services API helps you with that by giving you sort of a client hash that you can assign to the clients that you can then guarantee that you don't have kind of overlapping data or you don't download other data. Does this make sense so far? Okay, and so going through this really quick, I'm going to go back to the trusty demo again, and I'm going to just add a quick client ID to my code here so we can not keep ping-ponging changes back and forth. And you see we're adding the client ID to both the orders table and the tombstone table because it's needed in both places. And when we apply the updates, we're going to specify that the client ID is actually coming in as a hash. It's a client ID hash and it's an integer. So we have to modify all those same data access procs we did. And part of the reason I'm walking you through this is it's better to know than have to keep sort of churning all this code. But look how far we've come already. We've gone from sort of a basic cache to a cache that's being maintained for deletes, and now a cache that can be shared across multiple users and have updates without running into sort of collisions. And here's our actual newly updated query that's going to make sure that I just get the new things and I just get the new things that I didn't send. And this allows really for a lot of different client caches to exist and for the system to actually perform reasonably well because we're not doing anything new. And the key thing is that if you can actually add this kind of data to your application up front, it'll save you a ton of time down the road because a lot of people end up putting triggers on the table because they can't modify their application because the schema can't be modified. And so they end up putting triggers on to track the inserts and the updates. And that leads to other problems like reduced concurrency and things like that. So if you have flexibility over the application you're building, it's fairly nice. And you can see this is just basically the same thing for deletes. We're doing the same thing for deletes. So I'm going to go through and run all this code to create this stuff. And you'll see that when I select it at the end, based on the client ID I get the one row back and not more than one. So that's essentially what the code looks like to do that. Okay. So the other part that we haven't really seen is what happens if I'm looking to detect conflicts across users. So we talked about updates happening both places. We talked about maintaining the cache. What I haven't really shown you so far is this idea of how do I actually determine if there's a conflict that occurred, because now that every client has their view of the data and everyone's uploading changes, but yet everyone's still potentially disconnected, I have the opportunity and the potential for two users to override each other's data. And the answer for that really isn't anything groundbreaking. It's simply optimistic concurrency. And all you're really going to do at that point is compare the timestamp to the timestamp you thought you had and guarantee that the row hasn't moved, that the row hasn't changed. And as a result, then you end up with your own kind of optimistic concurrency mechanism to detect sort of conflicts. And then if you detect them, you can ultimately determine your own resolution path from there once they happen. And so I'm going to actually skip that portion of it because I want to keep moving through this because I want to show you sort of how things get a little bit better once we move to the SQL Server side. So who followed all this all the way through and thinks that they have a pretty good understanding of the different columns they would need and the queries they would need to take Compact Edition, you write a set of queries, and keep like a local copy of their backend server sort of in sync without any really kind of additional things besides some SQL statements and some stored procs. Did I convey that well enough for everyone to kind of get it at this point? Okay, awesome. All right, so with that in mind, here's kind of what we've done. We've gone through and said, in order to do this, you need to be able to track the changes on the server. You need to be able to add some sort of a client ID, and you have to roll sort of your own code to identify conflicts. Anytime you have like additional data, you end up with modifying the schema, which has a different appeal to people depending on their application. If I'm using an ISV's application where I don't own the database, and if I modify the database, that could be a big issue. It may not be. If you're rolling your own application, it's something interesting. It's definitely something worth looking into. Something I didn't cover was that delete table that existed on there is going to keep deletes for pretty much ever until you go through and clean them up. So you need some sort of a mechanism to purge the data out of that delete table so it doesn't grow sort of unbounded over time. And you need to purge that data only at an interval that is you're comfortable with, that your users will have had a chance to see those deletes. Because if you do it too aggressively, then people won't download the necessary deletes, and their cache or their local copy of the data will, of course, be out of convergence or non-convergent with the actual server database. And so you have to build a mechanism and a process to keep up with the deletes over time. There's other sort of things that are again somewhat subtle, but they're important. Is the idea of like backup and restore. If you restore the database, then obviously the timestamps sort of change, and now everyone in the topology gets confused because they don't know what data to send and what data to receive, and in some ways the clients are more current than the server. It just so happens that sometimes an interesting way to get the server back their data is if you have a bunch of offline clients that have all the data in totality, then they could potentially upload the data to the server if they knew how to do the appropriate thing. But nonetheless, it ends up somewhat being confused. And then, of course, the sort of other kind of problem that people run into, or the thing to keep in mind, is that putting triggers on a table, even in the case of a delete, sometimes people have a negative reaction to it because it is a separate table, it is a trigger, and it definitely affects sort of the ongoing performance. And so with that, I'm going to kind of turn into how SQL Server 2008 kind of takes the things that we've talked about already and makes them that much better. For sake of kind of delivery mechanism discussion, so the first version of Sync Services ships inside of Visual Studio 2008. We keep building on that capability in SQL Server 2008 by building things that are able to take advantage of change tracking and by adding support for peer-to-peer collaboration. And so both of those things will be available when SQL 2008 is available, but everything you're doing in Visual Studio today will just help you take advantage of it when it's out. So when we built change tracking inside of SQL 2008, we really wanted to do a couple of things. First, we wanted to make some of the queries that you were writing before perhaps a little bit easier. They're not super hard now, so that there's not a ton of room to expand on there, but things like deletes and stuff where you had to join to a separate table, it would be nice if it could be sort of more integrated. And the conflict detection, the optimistic concurrency stuff that you were doing now, it'd be great if there were some functions that were to help you so you don't end up trying to compare all these different columns to determine if something had changed between the insert timestamp, the update timestamp, and the delete timestamp. You'd really have to be able to look at all of those to determine if you had an update-delete conflict, for example. If one user updates the row, the other user deletes the row, and you want to detect that, you have to write some reasonably difficult logic of figuring that out and determining the right resolution. And so we really wanted to make that easy. We also wanted to make it a bit more integrated for DBAs. DBAs have always been looked at the replication thing and they love it and sort of hate it. They love it because it's a great thing to move the data around. On the other hand, there's a lot of stuff that gets created on the system. There's a lot of separate tables, store and forward queues, all these sort of things that happen. And we wanted to make it to where it was integrated like any other database feature so that a DBA could turn it on, developers could write code, and everyone would sort of be happy. And in order to do that, we wanted to really integrate it with the language and the tools and provide all the infrastructure that they're sort of used to. And then, of course, kind of most importantly was we wanted to have the absolute best synchronization experience when clients were connecting to SQL Server. We made the Sync Services API open, as you just saw. You can write against any database server. But the challenge was to make the SQL 2008 functionality compelling enough that you'd want to use it to couple with sort of an offline client or an offline cache. And so at the end, with the performance in mind, what we ended up with is kind of our goal was to be near or around sort of a second index was kind of our statement in the ground, where we said, you know, maintaining an index on a table, some people really don't hesitate to create another index on a reasonably concurrent system. If tracking the changes on the database by default was as expensive or around as expensive as a second index on the table, that would be a good benchmark to measure ourselves by. And so you see that for inserts, a second index is around 5%. A second index is actually a little bit slower at 13%. And a delete is still reasonably a bit faster than change tracking. And the delete one's particularly interesting because when you delete data from an index, or delete a row from a table, there's like a back-end process that really cleans up the row, and it's really just marking off a pointer, kind of like deleting a file from the file system. It just kind of marks it as deleted. And you can still do that, even to be clear. You don't have to delete the data. You could do that same thing on your database. But we actually have to copy the data into a separate table. So we'll never be as fast as a second index for deletes, because if you want to say what rows got deleted, you need the whole row to say, not the whole row, but you need the ID and the user and the things that we described to actually understand what happened. So you have to do some extra I/O to actually delete a row in change tracking. And so This example is using sort of trigger-based tracking. To be clear, I think you could build trigger-based tracking more efficient than this, and depending on how much metadata you put in line with your user data, you could get reasonably good performance numbers because you may not have a separate table for the inserts and updates. This implies that that change tracking we saw before is actually storing the inserts and updates in a secondary table. And so if in this case, what we see is that change tracking is a good bit faster than a trigger, and I think you'd find that to be consistently true when you played with the feature. So how does actually change tracking work and look on the system? So what we end up with, and hopefully everyone can see that at the bottom, is that we have the altered database syntax that turns on change tracking. Just like I mentioned to you before, with your own sort of delete process, if you built your own deletes table, we have the idea of a change retention that tells us how long to keep the changes. In this case, it's set for 30 days, which means all changes in the system are kept in this sort of secondary table for 30 days. And then you see there's a table level option down there that actually enables change tracking on the table level. So it's a database setting and then a table level setting. Now what happens inside the system is actually kind of neat from the perspective that existing applications now automatically track the changes without having a schema modification. And this is important because what we end up doing is we rewrite some of the query plans internally to maintain this internal change table you see on the side. And so when a query executes, we on the side sort of maintain that timestamp that you were seeing before to actually keep up with the change, but we don't break the existing applications. And so there's no schema change required. There's sort of no impact or intrusiveness to the actual turning on change tracking. Oops. When you actually select changes from the system, what you find is that there's a handful of new functions that exist: change version, change operation, column mask, and context. I'll explain those in a bit. And there's a change table syntax that actually lets you query the changes from the change table. And what you really end up doing as a developer is you join your user table with the change table and pass in your anchor, and you get all the new things. So it's very similar to what you saw before, but now it's just kind of managed inside the database system itself. The change version, change operation, and the column mask and context are actual columns coming from the change table that tell you, as you can imagine, the latest version of the row, whether it was an insert or update or a delete is what the operation flag is. And the column mask tells you if you have column tracking on, it'll actually tell you which columns have changed. And this is fairly important because if you have a large data type like file stream or something new in 2008, or a varchar, a very large varchar field, or a var binary field, it's really nice to not have to download that if someone just changed their first name or telephone number. And so it's a much easier way to kind of maintain good network performance by doing a little bit more work on the server without having to pay the price. You have a question? Good question. So the question is, I gotta repeat the question for the tape. The question is where's all that data being kept? Is it in TimpDB or is it in the physical database? It's actually in the physical database. It's in this internal change table. Now, one of our goals when we built it was to make it as precise as possible. So I'll show you in a second how it's fairly compact. It's a set of integers, and it does take extra space, but you know, we like to think disk drives are getting fairly inexpensive enough that the storage isn't too bad. Now, there is an interesting design choice we made when it came to storage. We actually optimized change tracking for minimal impact to operations over storage. And what I mean by that is every time a change happens, even an update, we just insert a new row in that change table. And then on enumeration, we find the latest one. And we chose to do that to prevent having to scan and look up and find the row we're going to update, because we didn't want to impact sort of online performance. So we had those kind of goals of making sure it was as efficient as possible. Any other questions before I keep going? Cool. Okay. So as we saw before, you need this idea of being able to set the client ID. And if you're willing to modify your table with sort of a client ID, or you want to do some other metadata to determine what change came from which user, you can do that. Well, with the change tracking actual feature, what we did was we actually extended the syntax to actually have this change context flag inside of the language itself. And so you actually set that as you apply changes from the client to the server. And what that does is simply identify with what client the changes are from. And that allows, of course, when you go to download the changes again, for you not to download changes that are from yourself. And so we sort of solve that ping pong problem by creating an easy way for a developer to set the context. Now, as you can imagine, these existing database applications that are firing the DML as they always would, sort of the normal online users, they're not going to set that context. It's going to show up as null, as not set. And that's fine, because when you write your download query, you're going to actually just not look for your own changes, and you'll still retrieve that stuff. So it's not mandatory that this is set. It's just a way for you to sort of achieve more functionality. You can also start to do some business logic sort of things on there if you want to set context to be something interesting besides just a client ID. And so we see that this sort of scenario that we just described before, that while there is server metadata there, there's no impact to your application, that now you see that if you want to maintain a cache, you just turn on change tracking and write the code on the client, and you're able to sort of do that without having to go through and implement a timestamp of update, a timestamp for an insert, and some sort of a special database field. And with that, I'm going to actually flip back over to the demo and show you how we set this up. Yes? Yeah, it's essentially what it is, but in the case of we'd go for something a little bit more unique. I mean, you could set, if it was a unique username, you could do that. We typically try to do like a hash. I think we use the MAC address or something to make sure that it's unique across it. But yeah, you would want it to be unique. Now, you could get tricky. You could decide that you wanted to share data. So let's call this the TechEd 07, and you could set context for a certain category of users to the same thing, and that would allow them to share data sort of on the same way. If you didn't want to filter it in the user table, you could use change tracking context. You could kind of overload that as a mechanism to identify that if you and I are interested in data, we could set the change tracking context the same, and we could actually use that as a mechanism to see interesting things. And so it's generally used to prevent data from being shared across people, to prevent data from looping around, but you could use it and set it the same on multiple people and then do something intelligent on it if you wanted to. So it's kind of general purpose, but its goal in mind was we have multiple users uploading data. It'd be nice to separate the data from one user to the next so we don't download unnecessary things, right? Same user on different machines is also an option. You could set that by user. The same user you could have 5 users sharing a machine. They could all set that context differently. So absolutely. You can set change tracking context however you like. What we do in the sync services bit is we try to give you some help with it. And so we try to give you a client ID to use. But you could, if you're in your code you wanted to, generate your own unique value, assign that to a user, no matter what machine that user logs into, he could set that client ID, right? So it doesn't have to be machine specific. It's just kind of, we think of remote nodes as like, it's my laptop, it's my device, it's my whatever. But it's entirely possible that if you worked in an environment where people shared machines or moved around the machines, you would associate client ID to a user in that case, and that's perfectly fine. So let me connect on over to the latest version of SQL. This is a real quick note on this. So ultimately, change tracking will be in every edition of SQL Server. The upcoming community technology preview has it in every edition, but Express, it will be in the follow-up update in SQL Express. So with that in mind, I'm going to show you kind of the database options themselves, and then we'll run through the code. Oops. So you see there's this change tracking property we've added here to the actual database, and it's in the management infrastructure. And you see that it has this idea of what the change retention should be and what the change period of it is. And the nice thing is this is actually fairly configurable. If you had that sort of a cache system where you have a secondary database server that's almost in sync to the second, and you just want to keep downloading new things to it, you can set that thing as low as hours or minutes. So you can keep it fairly purged fairly quickly, so you don't have to pay any extra storage costs on the actual system. One thing to note, and I think it's maybe somewhat obvious, but it is worth addressing, is that this is net data change here for change tracking, meaning it's very similar to having a timestamp on your table. Its goal is to tell you that something has changed, and given a watermark, be able to give you that data, the final data. It doesn't preserve sort of a history or an order of changes. We have a feature in the product called Change Data Capture, which is more designed for that, but it doesn't really, it's not really oriented for that. It's oriented more for just kind of downloading the data. So you see the final state of the data, which is important to understand. And you can turn the auto cleanup on or off. The nice thing about cleanup is it runs on sort of a background thread in the engine, so you'll find it to be fairly efficient. And then on the table levels, we actually have the change tracking property as well, and you can set, all this is available, of course, via DDL syntax. So, you know, alter database, set change tracking, the thing I just walked through sort of in the slide, allows you to configure this on your own. So, and that's kind of important for the administrator. So now I'm going to go through and actually walk you through some of the same examples. I'm not going to belabor this too much because I think at this point you guys get the idea, but I do want to make sure that everyone kind of understands and gets a view of how this would work with change tracking. And I guess I better make sure that it's turned on. And I'll go show you the quick little code that sets it up and turns it on. And hopefully the database is not in use, and it's not, which is great. Okay, and you see that this is our syntax here for actually altering the table, and the one above it created the database before. Uh-oh. Am I on the wrong? Sorry about that. Okay. I think my create table statement didn't get fired. Okay. Oh, thank you. The old connected to the wrong database will do it every time. Appreciate that. Oh, that's the right one. There it is. I think that was it. Okay, and it's telling me it's already enabled. Fantastic. Thank you very much. I'm going to go all the way to incremental delete since I've had to mess with this thing. So one of the real key advantages is that whether it's inserts, updates, or deletes, the syntax is the same. So you see that all I did in this query here, this is the one I want to focus on for a second. This is basically a procedure to download the changes. It's selecting the information from the orders table based on the last received anchor, which you see here. And in this case, it's only interested in change operation equal to D, which in this case is a delete. And so if you're interested in inserts, it would be the same query, you just change it to an I or a U. And so the nice thing about that is you don't end up in a cross sort of table join where if you had to put the trigger on the table and the separate table, in order to fully do synchronization, like I said before, you'd have to join across both the user data, the separate table, and the delete table to ensure that you didn't have like an update-delete conflict. And so this code is exactly the same from there. What you end up with is just this query that we had that was going to go through and delete the data and set it. But the nice thing is that this change table function is it's a row set function. And so if you're familiar with row set functions in SQL Server, what it does is you just specify the table that corresponds to the one you want from the change table. In this case, it's orders, and you pass in that database timestamp value, or in this case, it's actually the received anchor that comes from the change tracking function. And that's how you sort of set your low water mark and your high water mark. And so you can see that easily what we've done is we've downloaded the deletes without having to join and build a separate table. And so I'm going to keep moving through this and actually show you how the upload would be identically the same because there's nothing really to set context for yet. When we get to loopback, what we see is that this is that change tracking context that we were discussing before. And what I'm doing here is I'm actually setting my client ID to whatever I want to, and I'm associating the changes coming from the client with that client ID. And what that prevents me from having to do is download those changes from the user. And again, no changes to the underlying schema of the table. You could turn this on an existing legacy application, start synchronizing with it, write these queries without ever having to break the app or update the code on the backend server. And if we continue through this really quick, I'll flash through a bunch of slides when I get back through there. Conflict detection actually gets a bit easier perhaps, depending on how you look at it. But essentially what we're doing here, we're trying to make sure that the anchor is in line with the anchor that we have, which is very, very similar. We're just doing basically optimistic concurrency to make sure that the change version isn't different from the version that we thought. And this actual query here will tell us the version of the row. This is where we know what version the row is on relative to the version we're at. And this is about using that sort of system internal function, or sorry, that syntax that we described earlier, so you don't have to go through and write that code. Same thing here. This is a delete with conflict detection in there. That would have been about a 3-table join, and I should have taken more time on that, I apologize, to make sure you're checking for update delete conflicts in the non-sort of change tracking case. In this case, you're simply checking the anchor to make sure that it hasn't moved, and you're just specifying that the operation type is a delete in this case. And that's pretty much it. So hopefully from that you can get the kind of the general idea that with change tracking in 2008, we take a lot of sort of the hard problems that you had to deal with sort of on your own when it wasn't, and kind of solve them for you. But that doesn't mean, and one of the important tenets of the sync work we're doing is that it'll remain open. We won't couple it ever to sort of a specific database, because it's important that you have that flexibility. And our goal is to make sure that our server product is the easiest out there to build on. So we're just flying through this now of what we just saw. This is the updates by client, upload deletes by client. And again, the point is that you didn't really have to add any more metadata to the table. Once you set up change tracking once, it's all there. If you didn't happen to attend this presentation and you use change tracking, you wouldn't run out of sort of room where you try to do something new and go, oh, I can't do that. I need to go add a delete trigger, or I need to add a column. The point is that with 2008, we give you sort of everything you need. And so what I want to do kind of for the last sort of portion of the presentation is kind of describe to you how in the last version, in 2008, we actually introduced the collaboration capabilities for the Sync framework. So why would you actually do collaboration, and why is it sort of important? So the thing we've talked about so far is really offline caching and synchronization. And the common scenario for that, of course, is the Outlook Exchange. We're all in this room working on it. We're all working kind of disconnected on our mail, perhaps. But there's quite a few scenarios where a group of consultants or something work together, and they go to a customer site, and they can't contact the central server, but they still want to be able to exchange information. For anyone who's sort of used a SharePoint site and wanted it to work offline, once you sort of have it offline, you want to be able to work across users, because it'd be really nice to be able to kind of continue to do information flow no matter kind of how your network is connected. And so, believe it or not, actually adding the peer-to-peer or collaboration capabilities, as we call it, adds a bit more metadata than what you just saw. What we saw was about a timestamp relative to another timestamp. But once you go beyond that and you actually extend it towards peer-to-peer, things can get a bit more sophisticated. Well, one of the goals of the framework, of course, is to make this sort of easy for you, to make it to where you can connect these different systems together no matter how the network flows or where the data originated from. And when we went and built the peer provider in 2008, we wanted to not only allow sort of the network connection to kind of happen however it happens, meaning that you could go from offline to users back to offline, but we also wanted to be able to interoperate or synchronize with different stores. So it will be possible in 2008 to decide that you want to sync file data and relational data at the same time. And even if that data is on a file server and it's your offline copy of that file server, but then also if you want to synchronize with the database, you can do that. You could also do things like synchronize with Outlook. So you have contacts stored in a customers table in your relational database, but you also have the data stored in Outlook. It'd be great to have a consistent view of that data because so many people have information in multiple places. And our goal in doing this work was to make it possible and relatively easy for you to go through and do that. Now, it's different than offline, but it's still entirely possible using the framework and some of the services inside of it. And so you end up with a scenario where you can not only communicate kind of in any network topology, but you can also start to communicate with any data store. And you can start to incorporate data from multiple places so that if you have an application that needs to display pictures and relational or structured data and maybe Word documents, you can ensure that information is actually consistent at the end of a synchronization, regardless of the fact that it went to 3 different actual operational data stores. And that's fairly important as people kind of extend this stuff to the enterprise. Now, of course, keep in mind SQL Server 2008 also has new features like file stream, which are designed for similar sort of goals in mind, where it's an understanding that people have file data and database data. We want to make that stuff work as well together as possible, to where if we could store it really well inside the database, it makes things that much more efficient and easy to use. And so at the end of the day, what you end up with is sort of a common sort of framework for building relational sync on any relational database in SQL 2008. It's sort of what we started with in Visual Studio. We're extending beyond that in SQL 2008 by adding this ability to do collaboration and work with any data store. And so with that, what we have is a set of out-of-box providers for the sync framework, which we discussed previously. We have the ability to sort of build your own. Sync services for ADO.NET makes it really easy for you to build offline applications in Visual Studio. We give you Compact Edition, which has built-in change tracking. It's easy to deploy. We have sync services for ADO.NET, which is a set of sync programming APIs based on the ADO framework. We have a designer that helps you do the things I did in this demo if you're configuring a SQL 2005 sort of store. And of course, it remains flexible enough that you can write any sort of query and even extend it from 2-tier to N-tier if you want to communicate over WCF or something like that. That's entirely possible as well. Once SQL 2008 comes out, we have integrated change tracking. It takes all the things that we started in Visual Studio, makes them that much better. The performance gets better. It's a bit easier to write some of the more sophisticated, complicated scenarios. And we end up by adding the support for the peer provider, which gives you the ability to extend beyond sort of the hub spoke or the offline and actually do collaboration amongst multiple client machines and extend the data to places outside of databases and have sort of a consistent view. And with that, I'd like to thank you for coming. We have about 10 to 15 minutes left. I'd love to take questions. I'm super excited about the space. There is a couple of presentations that have already occurred. We're Friday afternoon, of course, but Steve does a great presentation on caching and offline in Visual Studio. It's more sort of the Visual Studio walkthrough of how you actually build that. I skipped that at the beginning. If you guys are interested and don't have questions, I can run through that now. And he also does a good presentation on the new features in Compact inside of Visual Studio 2008. So thank you very much for coming. I appreciate it. Hopefully you guys have had a great week. I'm here afterwards, and I'll be down at the booth for a little while. I think the booth may still be open, or it might have closed. So find me. It's closed. So go ahead and ask any questions you have. I'll be happy to answer them any way I can. Thank you very much, and thanks for coming. Appreciate it. First question. Great question. That's a great question. His question was, if I insert, update, delete, and then the guy synchronizes for the first time, what happens? So a cool thing happens in SQL 2008 smart enough to actually know that you never saw, you come in with a timestamp, it determines when it reads through the changes that you never saw it. That the delete is actually happened since your timestamp and you get nothing. You could do the same thing with the generic sync services, but you have to roll that code. Conversely, a little bit more sophisticated than that is if it's inserted and updated but you never saw it, what happens? It's actually just an insert reflective of the final state of the data. And so it's smart enough in 2008 to give you sort of the final state of the data. Now with those 2 timestamps I added, you could roll your own code again. Again, it's open enough to do that. But in 2008, you just call the query and it'll give you the data that you need. Additional questions? So, yes. How much information can you store in SQL Server Compact Edition? I believe it's 4 gigabytes. Yes, 4 gigabytes it is. Which is a lot of, that's still a good amount of data. Other questions? I'm sorry? No, great question. So what's in Visual Studio? I drove this thing primarily from the query kind of side because that was where the logic lived. In Visual Studio, it's sort of got everything for you, and it does a really fantastic job. I can run through it real quick for you. What it does is it actually goes through and sets up and generates the code you need to sync. I mean, at the end of the sync, what you have is a database, a set of queries that it's going to call on the server, and essentially a cache. And it even goes so far as to let you bind a data set to that to where you're really like almost there. Like you've got kind of that Outlook experience. You just have to decide whether you want a list box or an edit box or whatever. I'll pop that up as folks ask questions so you guys can go through and see that. Go ahead. Other questions? I can hopefully multitask until they kick me out of here. So out of the folks who were planning on building an offline sort of application, did you guys find this useful? Good deal. Okay, so what I'm going to do is go through and add a new item. There's this actual project type called local database cache. Corresponds nicely to the things we've been discussing. And I go through and add that. And if my demos continue to somewhat behave, I'm going to point this guy to the Express connection. And it's going to create this new SDS file that you can see, which is basically a compact edition database. And what I'm going to do is actually add tables that I want to cache here. In this case, I'm going to go through and actually add the orders table. And you see there's something smart that's happening here. It's actually saying compare updates using what? In this case, it's got last edit date. And it found that there's a timestamp on the table, and it picked it. It found that the inserts actually need this creation date, and it's going to go add it. And it found that it needs this sort of ordered tombstone table to go through and do that. And so it's actually doing kind of the portion that I walked you through the demo. The reason I walked you through that is I want you to sort of have the knowledge so you can do whatever you want to do. This is choosing to use trigger tracking and to modify your columns to put timestamps on it because that's sort of the easiest thing to do. But you may be in a situation where you can't modify the schema, and so you're left creating triggers and things because you can't touch the actual source system. This goes through that way, but keep in mind it is smart enough to say, hey, I actually don't even want to detect updates, or I'm not interested in tracking deletes. I just want inserts and updates. And so when this thing is done, you can have the choice to run the script so you can ship it off to your administrator. They can run them for you, or it'll run them for you sort of on the fly and make it all happen. And of course, there's even another option that says, hey, I want to actually get the new and updated things, or I just want to refresh the cache every time. And this is actually a reasonably valid option for somebody who just wants that sort of local data on their client, and they don't want to have to roll their code to do the sort of select star and download it. They want to use sort of the things that we've provided there. And so when I press OK here, it's going to go through and work its magic. And we didn't actually have the somewhat of the runtime code here, but it's useful to know that, like any project, we always run out of time, just like you guys do in your projects. But we did go through and give you all the code you need to actually synchronize the agent. And so this code you just copy and paste and put inside your code, and this does sort of the heavy lifting of synchronization for you, of calling the actual agent and running the code. This is all it really takes to launch the sync agent. So with that, I'm going to press OK here and hope that everything works well. And this guy should download a local database and create a local database file that now it goes into this sort of data source configuration wizard because I have this cool little piece of data on my client machine and I want to do something with it. So in this case, I'm going to take this orders table, make a nice little data set out of it. And when I'm done, This thing's going to create a nice data set inside of my project that I can go through and actually bind controls to, as you'd imagine. And what we've actually got here is a situation where we're going to keep this data set in sync. It's fairly nice to know that after a few clicks of the wizard, I've written no code. We've modified the backend database. We're tracking the data. I've written the code to synchronize that data. And now what I'm going to do is actually just tie this, this data set that I downloaded to a list box so we can see that guy. Oh. And I want to display the actual, for the order, let's display the actual contact name. So at this point I'm in, this is nothing new at this point. I'm actually in just Visual Studio doing this sort of the normal thing. And when I preview the data, hopefully you'll see, oh. I bet you if I go query my table, there's nothing in the orders table. Anyone want to take a bet? So the point though is that without really writing any code, without having to do a lot of the difficult logic, I was able to easily kind of maintain that local cache. Let's plop a row in there real quick. There we go. See how if I can work around my schema violations. Oh, it wants a row good. The pain of working with goods, huh? Nope. Okay, that's not going to work. That's going to take too long. I'm going to sit here and fumble with it. So you get the idea around going through and without really any code, that's kind of how it works. So what it did was it queried the database, created the local data sets, I bind the controls to it, and now the synchronization sort of happens between the backend database, the local database, and then the data sets are being queried off the local database, where now I have this model where things are happening sort of, if the network goes down, my application's fine. It doesn't care, right? I'm working off of the local data. And then periodically I'm calling synchronize, and it's keeping that sort of data in the loop. And one nice, really cool thing to do is to actually have your GUI be somewhat sync aware, to where if data changes in the underlying database, you can repopulate the form, you can notify the user, and orders come in, whatever it may be. And so you can see that with Visual Studio and the things that we've done, hopefully it feels like it's very easy for you to kind of go build an offline application that also does synchronization. Yep. And a concurrency problem, you get an exception. So if I run a query and it fails on the server, is that what you mean by concurrency problem? Yeah, so you would have to, in this scenario where you're writing your own code, the question is how do you handle kind of the this application so far has basically written the code to go through and actually fetch the data from the server. It's written the code to upload the changes. It's actually assuming that it's going to send it both ways, and it's got conflict detection sort of stuff built into it based on the timestamp values you have. Yes, and you have to handle it. Yeah, but resolution is ultimately, Steve, how can we customize a resolution beyond that? Yeah, you can write whatever code you want. Now, ultimately, most sync systems, their goal ultimately becomes detecting the conflict. You know, making a default choice is sort of up to you because there's no real way for a product out of the box to kind of get it right. There's another question. There's a bunch of questions going up. Yes? Good questions. The question is, what would you need to connect to an Oracle database? Create a connection. That's it. You just create a connection. And then the designer is designed to work with SQL Server, but you can ultimately write any queries you want to it. We won't modify an Oracle database on the back end automatically because just, you know, we have to maintain all the syntax differences. But you can query, it's just ADO. It's literally just using ADO 2.0. It's got sync basically extensions added to it. We add a select incremental command to that. A nice, look at Steve's blog, and there's some samples out there that'll show you sort of how to get going with sort of any database of doing that. Yes, question? Yeah, great question. So what if the data has never been inserted or deleted and you want to basically download it? Let's start there. Is that a fair interpretation?
Yes, I mean, the data may already exist at the table. It's just that due to permissions, you're not allowed to see it.
Yes. Yeah, once it becomes available for you to get it, right? So there's a couple of things. First, if it's the first time you're seeing the table ever, you could set your watermark to 0 or your timestamp to 0, and you'll get all the data, right? If it's data that exists in the table, but you modify the permissions, you can actually do what we call a dummy update, and it just advance the timestamp. That'll cause everyone to look at it again. It'll look like it changed, even though it may not have changed, so you'll just flag it. The change tracking stuff actually has its own permissions on it. So if you have fine-grained security, change tracking in 2008 actually does that stuff for you automatically. You actually grant permissions and you can have views on it, and it works much more like a normal database would. So there's no like special sync sort of filtering that has to occur. Does that make sense?
Yep.
Yes. Yeah, great question. Yes. Yep, exactly. So one thing I didn't cover in here, and it's covered in the, I think we have a fairly robust section on the WCF aspect of it, is you can take what we call from two-tier, where the client connects to the database directly, and you can actually host the server-side portion that knows how to query the server on a web server, on a web front end, and expose that data over a web service. And so that's the way that would work. And in fact, we expect that to be a very common deployment. There's some things inside of the designer actually that help configure the WCF stuff for you, so you can configure that for you. But if you have an existing kind of protocol that your clients call, you can easily extend that with this technology. So yeah, but it's designed for that in mind, to kind of move it around. We had that kind of that flexibility goal. Yes. It's a hidden table. The change table object, is that a real table or is it a hidden table? Sorry, I have to repeat for the camera. Yeah, the answer is it's a hidden table. It's a real table, but you can't really access it as a user. Does it use identities? No, it requires a primary key on it, which is what you have to have on your table, and it uses that to know which row it's looking for. Yeah, I'm sorry, can you repeat the question? Yes. Yes. Yeah, good question. So I think you're saying the question is, I have a transaction that spans multiple tables, right? And I'm going to commit that transaction. Does it figure out to track the changes appropriately for the transaction? Yeah, so the way that it works is it's table by table tracking. So you're not going to get a transactionally consistent view. What you'll get is, if you had change tracking on all three tables and your transaction touched all three tables, you'll get changes in your change table on all three tables. What you won't have is the ability to reconstruct the transaction. For that, you need some sort of a log reading or some sort of a transactionally consistent view. This is really primarily more about making sure each table is tracked. But yeah, any change that touches the table, whether it's part of a long-running transaction or a nested transaction or whatever, it'll be tracked appropriately. Go ahead. Yeah, it's the final study. Go ahead. Did you have a follow-up? Yeah, that's right. It's basically modifying all the queries that hit that table. It's modifying those, their query plan, because when you run a query on the server, it goes through the algebraizer and does all this smart stuff to figure out how it's going to actually update that data. We hook in at that level. So seamless to the client, it does it. Now, it is a best practice, and it's absolutely what we recommend to run your queries with snapshot isolation level on, so that we have a guaranteed consistent view. That is the best practice for when you run change tracking. We absolutely recommend that snapshot isolation be turned on. I'm getting to get off the stage flag from the folks in the back, so I'm out of time. But please follow up afterwards if you'd like. I really appreciate you guys coming by. Thank you very much. Hopefully it's been a great week. I really appreciated presenting to you guys. Thanks.